Hi, this is Mr. McConley, and we are at my house today, and this is going to be BKW General Physics. We're going to talk about centripetal forces, centripetal accelerations, basically things spinning in circles. So in order to do that, we have a bicycle here, and we're going to use that so that people can see and I can point as the wheel spins on the bike. So I'm going to take the camera. So if you pull that wheel up for a second here, if we're looking at a wheel such as this one, then and it's spinning, so I'll get it spinning. A spinning wheel, if there was a rock on the wheel right now, that rock would want to go flying off and it would want to shoot straight out, called tangent. So basically, if the rock was right here and the wheel was spinning, that rock would leave the wheel and it would just keep going straight and fly in this direction. That's the direction of the velocity of the wheel. So the wheel is spinning in a circle, but its velocity is tangent. Now, the acceleration and the force are different though. So as a wheel spins, it has centripetal or center-seeking acceleration. So what happens is, in order for this wheel to keep spinning, this part, if I stop it again, this part of the wheel is somehow being pulled inward towards the hub, center-seeking, centripetal, which makes sense because all these little spokes are holding the outside, the rim and the tire to the hub of the wheel. So as this spins, it's pulling towards the middle, and that's why we call it centripetal or center-seeking. Now that provides an interesting dynamics in physics, because when something spins like this and the force and the acceleration is center-seeking, that makes it hard for the wheel to want to tip over. So once you get that wheel spinning, that wheel, looking at it from the front now, that wheel does not want to tip side to side anymore. It wants to stay spinning straight because the forces are in towards the center of the hub. So this is why riding a bicycle is actually not that hard, because although you're on these skinny wheels, all the forces are center-seeking, which adds and helps with balancing. So I'm just going to have Farmer Andrew here do some different things on a bike. First of all, we'll just have him ride around, and if you can just get riding at a steady pace and then let go of the handlebars for a second to show that it balances easily, that would be great. You can ride down the driveway a ways. I missed that one. Do it again.
Okay.
Just go ahead and go that way. Yeah, that's good. So as you can see, that bike really didn't want to tip over once those wheels were spinning. That's the centripetal force, or the center-seeking force of each one of those wheels. So go ahead and pull a wheelie. This is, of course, an applied force. But again, once he pulls that wheelie and starts riding a wheelie there, that was cool. Once he starts riding that wheelie, the bike really wants to stay in that upward position because of the centripetal forces. So for today, I'm Mr. McConley. This has been centripetal force, centripetal acceleration for BKW General Physics.